Okay, here's our video today on geometry, points, lines, and planes. And it's a very basic video because these are the beginnings of geometry. You should know these terms, and some of them I'm sure you do already. So I'm sure we know what a point is. We just make a point, right? What's the point? Right? So there's a point, and I can call it point A, I can call it point B, and so forth, or whatever letter you want to use. So you should know a point indicates a location on the plane or in space. Indicates a location. There's point A, there's point B in examples. Let me get a clean page and we'll do line. So we know what a point is, and we'll do line. Maybe we'll change the color. See how use yellow. See how yellow is. A little better, it comes out more. So a line is a straight path. Straight path in the woods. Probably don't find straight paths too much, right? If you see a straight path, you probably think, well, it's probably made by mankind. Usually they're curved and so forth. Well, anyway, a straight path, and it's extending. Here's the key. Extending infinitely, right? Spell infinitely. How do you spell it? There we go. Lost my train of thought. Infinitely. In opposite directions. So in other words, you have that symbol like this. It's going from the left infinitely and to the right infinitely. There's no starting position on a line, technically, right? So we could label a line, let's say we had a line here, right? Let's pretend it's straight. And let's say we had that was B and there was a point there, C. We can say this is line BC. Say it's line, there's a symbol line BC. Sometimes they'll just write a letter for a line, and a lot of times they use L. Like that could be L. It could be line L. Usually you see line L or line M. So remember, line doesn't have a beginning or an end. But a line segment is part of a line. Is part of a line. So when you see a line like that, and it says AB, it's not a line, it's a line segment. It has an endpoint on both ends, right? So if you see something like this with a starting position, starting point A and ending point B, or both endpoints, that's a line segment. So remember, a line doesn't have a starting point, but a line segment does. So go back if you need that. Let's erase this now. Or maybe we'll squeeze in, use another color. See how this blue works. We'll say array. So array has a endpoint or a starting point, and then it goes on forever. So it's like a mixture of a line segment and a line. That's what array is. So let's say we call that G. And maybe we have another point here, H. So we can call this ray GH. Remember, array is part of a line. Part of a line. That starts at a point, in this case point G, and extends forever. Infinitely. Let's try to spell it again. There we go. Getting better at spelling today. So we have a ray, a line segment. We have a dot we talked about before. And we have a line. So let's clear this out. And go back if you need to. Clear it out. Now if we took two rays and we have them meet, we can get a vertex. A vertex. So here's one ray. And if they meet, there's another ray. So we have two rays, two sides, and right here with the arrow, that's the vertex. That's the vertex. So the vertex is the point of intersection of two or more line segments, or rays, where they intersect. The point of two or more line segments, or rays. And we can call that vertex A or vertex B and so forth. So they can label that A. And then there could be a point here, maybe point B. There could be a point here, C. And then we have, of course, the angle. So an angle is formed by two rays with the same endpoint. So we have two rays, as you see here. Two rays, they're intersecting at the vertex. So here is it. And this angle right here, this is the angle. Inside here, color it over. See how it made a certain angle. These two lines made a certain angle. For example, if we did this, and you saw that little box, that's a 90-degree angle, like an L. And then you can have, if it was half that, you can have two 45-degree angles and so forth. So we have an angle, and they're usually measured in radians, which you'll learn about later on, radians or degrees, like I mentioned before. And they're written like this. So let's go back here. We'll have a little arrow here. So let's say you had, here's a ray. There's another ray. We don't know the degree because we need a protractor for that, but we can guess. And sometimes you'll see a line indicating the angle. Here's the vertex, vertex A. And so, and let's say we had other points in here just for identification. There's point B and there's point C. We can say this is angle. That's the symbol for angle. And we could say the angle, the vertex should be in the middle. So we could say this is angle BAC or CAB. But since the vertex is A, never put A first or last. That's angles. All right, let's clear that out. We'll do three more terms for today. Clear it out here. Maybe we'll stay with yellow. And we'll just talk about a triangle. We all know what a triangle is. The symbol for triangle, obviously, is a triangle. So if we if we draw it, that is, if we draw a triangle, we'll have, you can have, as you can see now, we have three vertices, the plural for vertex, right? So there's vertex A and vertex B and vertex C. And of course, you know, you can see the angles inside of it. And the total degrees of a triangle have to sum to 180 degrees. So we could say this is triangle ABC. Now, since there are three vertices, it doesn't matter how you write this. You can write it CBA or BAC. It's the same thing. Two more terms. We have parallel lines. So in geometry, parallel lines never meet. They're just two lines that will never meet. They're always the same distance apart. They never meet. Big thing for parallel lines. Never meet. They're just waving to each other from a distance. And the symbol for it is written like this. So you'll see it's almost like that absolute value symbol. It's just two lines. And you can say, if you see something like this, you can see line L is parallel to line M. That's what it means. Line L is parallel to line M. And you may have heard this as, you're walking parallel to the river, and so forth. And the last term is perpendicular. And perpendicular lines, they intersect. It's like you're at an intersection on a avenue in a road. They intersect, and it's written like this. Let's say we have one line, line L, and it intersects line M. Well, we did forget one term, actually, which is in the title, planes. Not an airplane. We should talk about a plane. By the way, a lot of the things we talked about are one-dimensional. And the triangle is two-dimensional. It's flat and two-dimensional. And a plane is two-dimensional also. It's a two-dimensional flat surface. So let's clear this out. Give it a little clear. And we have our plane. So we can have a flat surface. So it's drawn like this so we can see this, but it actually, in all directions, it extends infinitely. There's that word infinitely again, right? So it's a flat surface. Make sure it's a flat, two-dimensional, 2D surface. And in every direction, it extends infinitely. And use capital letters on a plane, right? So you can have points on the plane like this or this and this, right? And that could be P, that could be S, that could be Q. And then in the top corner, usually the top right, they'll have a letter, let's say N. And that's what they use for the name of the plane. So this is plane N. Just that, just plane N. You can name this plane but based on the points. We can call this plane N. Or we can call it plane QSP because those are points on the plane. Okay, we'll talk about more terms on the next video.